Alright, so now we're going to do the last three here, and we're all done. We got CO3, now we have a polyatomic ion, so we have to consider this charge. So we have a C and three O's. Now carbon's got 4, oxygen's got 6, so we end up 4 plus 6 is 22. I'm sorry, 4 plus 18 is 22 electrons. Now the C and the three O's will not bond. They will not be able to hook up nicely, and everybody gets their octet if they only have 22 electrons between all three of them. So that's why they have this charge. This -2 is important. -2 means it's going to have 2 more negatives than it originally had, or than it has for protons. So we're going to take this 24 and add 2 more to it, and that 24 is going to become, 22 is going to become 24. So now we've got 24 electrons in our bank. So here we go. What's your central atom? Well, there's only one carbon, and it's carbon, so we usually put that in the center. Connect it to your oxygens. There's 6, 2, 4, 6 in the bonds, so 24 minus 6 is 18 electrons. Give the outer guys an octet. There's 6 there. 18 is now down to 12. Give this guy 6. 12 is down to 6, and give the last guy 6. And that should empty out our bank, which is good because we want our bank to be at 0. But it's bad for carbon here because oxygens are all happy, but carbon's sitting there with only 6 valence electrons. It needs more than that. And there are no more in the bank to just throw 2 up here. That's why it's very important to keep track of your bank so you know what kind of situation you are in at the end now. I realize there aren't 2 to throw up here, so carbon has to look at the oxygens and ask one of them to share. So this oxygen, eeny, meeny, miny, moe, pick your favorite one, doesn't matter. This oxygen is going to donate 2 electrons, put them on a little highway between the 2 atoms, and they're going to zip around carbon and around this oxygen, and they're shared. So we have a double bond there. Now if you notice, there are 3 elements, again, or 3 atoms bonded to the central one. So again, we have trigonal. And then we ask ourselves, does it lay flat on the same plane? Is it trigonal planar, or does it sit up like a pyramid? Now this particular one does not have an extra set of electrons anywhere pushing these guys towards each other. So this one is just going to lay flat. So we have our central atom, we have one up here, we have 1 and 1. All evenly spaced, and they all lay on the same plane, so it's planar. Okay. Alright, CH3F. Let's add these guys up. We got carbon, there's 1 of them, hydrogen, there's 3 of them, and fluorine, there's only 1. So carbon's got 4, 1 times 4 is 4. Hydrogen, there's 1 of, so there's 3. I'm sorry, there's 3 times 1. And fluorine's got 7. 1 times 7 is still 7. Alright, so we have 14 electrons, no charge, so that's all we have, 14. So we're going to pick our central atom. Well, I told you, pick the one that there's 1 of, so there's 1 carbon, 1 fluorine. When in doubt, go with carbon. So put carbon in your center and surround it by the other guys. So I'm going to put an H, an H, an H, and an F. Now it doesn't matter if you have the F over here, if you have the F on top, as long as you have the F in there somewhere. So now we're going to subtract 2, 4, 6, 8 from our bank. So 14 minus 8 is 6. Then it says give the outer guys an octet. Remember, you never, ever, ever draw on hydrogen. No dots on hydrogen, only a single bond, which it's all set already with. So now you're going to put the 6 on fluorine, give it the octet. And fluorine's all set, nice and happy now. 6 goes down to 0, that's a good thing. And then we go back to check if everybody's happy. Fluorine, we just made it happy. The little hydrogens each have their 2, they're thrilled. And carbon in the center has 2, 4, 6, 8, that one's all set. We look at this, we've got an atom in the center, and then we've got 4 bonded to it. The only picture that you know of that has 4 atoms bonded to it is this one. And this is tetra, tetra means 4, hedral. And these are 4 atoms all spread out evenly. Last one, HCN. Here we go, we're almost done. H, there's 1 times 1 valence electron. There's carbon, there's 1 of them, and there's 4 valence electrons. And nitrogen, there's only 1 of them, and there's 5 valence electrons. So we've got 1 and 4 and 5, grand total 10 electrons. So that's what we have to work with in our bank. Pick your central atom. In this case, it's going to be carbon. Remember when I said if you only have 1 of them, the next thing you look at is where's carbon. And I'm just going to put these in order right in this, or in the same order that they are on my formula. So I just connected the outer guys with a single bond, so 10 is down to 6. Then I look at what I have here. Can I give the outer guys an octet? I can't add any more to hydrogen. Hydrogen already has its 2, so that's set. So I'm going to give 6 of them to nitrogen and give nitrogen the octet. So there goes my 6. I'm down to 0. Now that's good because I'm at 0, but that's bad for carbon because carbon can't look at the bank and say, are there any for me? Instead, carbon's going to look at nitrogen. It can't look at hydrogen because hydrogen has no electrons and it's keeping for itself to donate. So it can only look at nitrogen. So it's going to look at the nitrogen and say, can you put some on a highway between the 2 of us? I won't keep them. I'm just going to share them with you. I'll send them back and forth between the 2 of us so we both think that we have the octet. So we end up drawing a triple bond, 1, 2, 3 lines. And if we want to rewrite this a little bit neater, and this is actually what your 3D structure is going to look like also, it's just going to be a nice linear molecule. Okay, and this one is linear. Now it's not bent at all because there's no extra unshared electrons on the central atom forcing the 2 outside guys close to each other. This is just a nice straight line, linear. Okay, and that's it. All right, good luck on your exam.